All right, so let's continue on with our graph. So last time we finished up, let me switch over to our project. We finished up our we finished up our initial graph, and then we said to ourselves, you know what? This seems pretty tedious. It would be nice to be able to read that stuff in from a file so that we could maybe store information about our maps inside of a file. What we've created here so far is just this is just a flat file that says there's going to be 7 towns. So at this point, you're very reliant on knowing the format of that file, right? So we're saying, okay, well, I'm going to sneak a number in there and say there's going to be 7 towns, and then here's going to be the towns. And then maybe after that, we can have another, maybe we have a line that, you know, is, I don't know, what's that, 6 asterisks. We can have a line that's 6 asterisks, and we say when we hit that, that flags us to know that the next thing we're going to read in is maybe the number of roads that are going to exist. Does that kind of make sense? So at this point, we're writing this very proprietary solution, and we're saying, you know, okay, I'm gonna make my my file match up to what I need my program to do. So this is going to be a very old style way of doing it, and we might say that this is problematic because whoever writes your input file needs to know about your special made up syntax for this, right? Could I, well, let me ask you this question. If we just think about our towns, the reason we put this 7 in here is because we decided, why don't we store this in an array? And what did we do? We created our file stream to our cities.txt. As long as it's successfully opened, we read in the very first line. We converted that new style string to an old style string, and then converted that guy to a number. That's what that A to I does. So ultimately, number of towns was that 7 in our case here. So then we built our array with the correct amount of memory. If we're just starting to look at this, we would say, okay, I would prefer not to have to put that 7 there. That would probably be better. That would make our file less proprietary. We're basically just saying, hey, just put all the city names in there. So if I had my file like this, what could we do to create an array of the correct size based on the number of things that are in this file? Alternatively, what could we have done? We could just make it an array of 10,000 things. Just say, don't put more than 10,000 things in the file. Let's just hope for the best. But let's say my input file looks like this, and my goal is to have the exact correct size array to hold these guys, but I don't want to have to include a number in here to pull it off. How might we accomplish that? Go ahead.
We maybe use like the line things that move through and then like increment the count each time we don't return null.
Okay, so go through it once, count the lines, then say, okay, good, go through it again and actually fill up the stuff, right? I guess you could say, well, let's take the shortcut and maybe create the 10,000 bucket array, fill it up as we're going, and then move it into another array. But then you're still giving yourself the artificial limit of 10,000. So let's go with the approach of reading it in once to get the number of lines. Let's see here. So this is where we try to open it. We're going to have an int count that'll start off at 0. I'll go ahead and comment out these couple of lines. And rather than outputting the line here, what we'll say is count plus plus. So we'll increment the number of things we ran into. And then when all is said and done, let's make sure we got the right count size. So there's our 7. So now we know how many elements there's going to be. So now we just do the same logic again and read the stuff in a second time. Now we could do this a couple of different ways. What I might do is I might create a function that does something like, let's have this guy return a town pointer called get towns. So we'll prototype that function there. We'll go below main here. Well, we didn't have to go below main, but that just tends to be where I put my functions. We'll go ahead and have our town pointer get towns. I'm going to take all of this logic here. We'll throw it into my get towns function. Okay, and here, I'll take this stuff out for now, just to keep this somewhat concise. Now I know I'm going to have to make 2 passes through this file, right? But I also need to think about, okay, well, once I have my file open, I don't want to close it after I've counted the number of files. I kind of want to go back to the beginning. So one option would be I could just close it and then reopen it, right? And that would presumably reset the file. There's probably also a function that allows me to go back to the beginning of a file. Like reset, something like that. This seeks to the beginning. I'm not sure I'm necessarily a fan of that. Nothing obvious. So we'll just close it and jump back rather than spending too much time looking for it. I'm sure there's a way to, well, we just saw there's a way to seek back to the beginning of it. But for us, I know I want to do something twice. So I'll create a for loop for int I is equal to 0, I is less than 2, I plus plus. So I want to go through and I want to make 2 passes through this file. Pass 1 is to count the number of things that are in the file. Pass 2 will be to add, will be to then create my array and fill it up. Now I could do this in 2 back-to-back chunks. You know, I can have basically this code and then duplicate this code a second time. I could do all that. And I need to move my this stuff down into my function too. Okay, now this guy here effectively opens a file. So the first time through this loop, I want to open that file. And then I'm going to say, well, if it's open, and actually I could even skip the idea about asking if it's open if I wanted to make this look a little bit more concise. I could just let it give a crash type thing. That seems nice. All right, any way you cut it, the very first thing we're going to do in our for loop is open the file. The last thing we're going to do in our for loop is close the file. Now, inside here, we're either counting or collecting, right? So I'm going to come here before this guy, and I'm going to create a town pointer. Let's call this guy collection of towns, like this. This is a variable I intend to fill up with a value. Okay. So inside here, if I is equivalent to 0, I'm doing my counting stuff. Else, I'm going to put a value inside of my collection of towns. Collection of towns at bucket. I'm going to need to use like a counter here. So we'll say int pause starts off at 0. Collection of towns at bucket pause is equal to whatever was read in by line, but I need to build a new town out of that, giving it the name of the town. So our constructor, remember up here, the constructor for town is new town, and you pass it the name of the town. Presumably, I just read in the name of the town inside of this string called line. But that's only if I'm looking at my second pass through this. So my first pass through here, this while loop that's going through the file, if I'm looking at a 0, my first pass, I'm just counting. After I'm out of this while loop, I'm always going to close the file, but I'm going to ask the question, if I is equal to 0, that means I now know how many towns there are. So get my memory. So this is where I will actually give collection of towns a value. And we'll review what we saw last time. So I could do something like this, collection of towns. Well, I'll just write pseudo-ish right here. I could say that guy is, I want an array of that many towns. Okay, remember we looked last time, I think I still have it up here. No, I took it out. We looked at 2 different ways of creating an array. One way is we actually asked for memory. The other way, we took kind of this shortcut thing where, you know, I would say something like, I want an int array capable of holding 10 things. Okay, so if we assume that this guy follows that syntax, I'm kind of cheating a little bit here because you're not able to separate the two. If you're going to create a collection of towns with count number of things, I would have had to say this was a town collection of towns thing like this, when I had actually already defined it up here. Otherwise, it wouldn't have known what I was talking about here. All right, but what would be the problem with me writing that in this case? Given that I'm doing this inside of a function called get towns, whose ultimate job it is to return an array of towns. What's the downside of building an array this way that we talked about last class? It deals with who owns the memory, who's responsible for making the mess. If I use that shortcut like that, and I build this array in this scope, this is the current scope is the function that is get towns. When get towns ends, gives that memory back. So even though I presumably am going to be returning that pointer, it's going to point to a place that doesn't exist anymore. It's dead. Because the operating system reclaimed that memory at the end of this function because of how I asked for that memory, like this. So I mentioned last time that it's never going to be wrong to use the scarier syntax for asking for memory, where we're going to say, we want to go ahead. We've defined a variable called collection of towns already that knows how to hold a town pointer. So now I'm going to go ahead and put a town pointer in there. I'm going to put a memory address which points to a town. So down here, if this was my first pass through here, I'm going to set collection of towns equal to the town pointer version of memory allocate count times size of town pointer. Now, if you remember last time, memory allocate by default returns a void pointer. And a void pointer is a generic memory address that the default value is size of memory address. It doesn't know when I go to bucket 0 or bucket 1 or bucket 5, it doesn't know to take 5 town size steps through memory to get to that bucket 5. It will take 5 generic memory address size steps, which actually in this case would work out fine because the thing I'm storing in there is a memory address. But that's kind of lucky that it would work out fine, that we kind of have a double pointer going on here, right? Bucket 3 of this array will hold a memory address, which points to where that actual town lives. Bucket 4 will hold a different memory address, which points to where some other actual town lives. So a town pointer is the same thing as any other kind of pointer. It's the size of a memory address, which would be the default value for a void pointer. It would still be, well, it's going to yell at you anyways, but it's always a good idea for you to tell C++ or C in that case, what kind of value you're working with here. Because presumably we're saying, I'm asking for contiguous memory. I'd like to be able to walk through that memory using array syntax. So you need to know the size steps I expect you to take when I say go to bucket 5. All right, so I'm typecasting what's coming out of malloc. I'm saying treat that void pointer as a town pointer. And how much memory do I need? Well, I needed this many. That's the number of towns I counted, times however big a town pointer is, which probably in a 64-bit operating system is, I think I mentioned, I don't think it was last time, but some other, we might say we presume that a memory address in a 64-bit operating system is 8 bytes, 64 bits. If you look at modern versions of Linux, it's actually 48 bits with a, because they, for security, they subdivide memory into like a administrator memory that has 2 to the 16th, 0 to 65,535. So 65,536 unique addresses that are only for administrator use. And then they give you 2 to the 48th power addresses for your various processes that are running in user space. So it's more of an operating systems thing. But the point is we don't need to have that memorized. We're just going to ask the current operating system, how big is this dude? He's going to give you a number in bytes. We're going to multiply that number by whatever our count is, and that's the amount of memory we're going to request. Make some sense? So ultimately here, if this was my first pass through my for loop, I've just done my counting. So go ahead and give a value to collection of towns. If this wasn't my first pass, it was my second pass, presumably I have finished filling up my collection of towns. So I can go ahead and return collection of towns. Stop my for loop there. While loop ends there. Okay, so let's walk through this. Variable for holding my memory address. I don't remember saying pos plus plus. So I haven't found any cities yet. This is where my memory address for my array will live. When I start filling it up, I'm going to have to know where inside my array I am, bucket 0, bucket 1, bucket 2, so on and so forth. I'm going to go through and do something twice. First time I'm counting the number of towns. Second time I'm reading in the towns and actually building them. I will, each time I go through that, I will reopen the file, which resets it to the beginning of it. So I'll open the file. So as long as this guy returns true, I haven't read the end of the file. If I'm in my first pass through the for loop, I'll be incrementing my count. Otherwise, if I'm on my second pass to the for loop, I know that collection of towns already has a value. So I'm going to set bucket pos equal to a new town with the name of the line I just read. And then I'll increment pos. So the next time through, it puts it at the next bucket of the array. When this while loop ends, that means I've read through every element of the file. I'll go ahead and close that file. Then I'll ask the question, did I just finish counting? That's what that guy asks, right? Did I just finish counting? If I did, go ahead and give our array its memory. Otherwise, if this was my second pass, I just finished filling it all up. And the job of get towns was to return my array of towns. So that's what I'll do. Make some sense? So now what I can do, I'll just comment this stuff out for the moment. I'll go ahead and I'm going to create a town pointer. We'll call this guy the towns. And he's going to equal whatever get towns gives them. And we just wrote get towns, right? Now, just to test this, well, here we can do a quick test. See out the towns at bucket 3. Dot. Oh, actually, we taught towns how to display themselves, didn't we? A town knows how to display itself, so we don't need to do a C out. We'll just tell this town to display itself, proving that we read in that town. Town pointer collection of towns. When we built it, we say collection of towns at bucket pos is equal to a new town line. Give me a memory address. This is saying in this bucket of the array, bucket pause, I'm setting it equal to whatever the new keyword returns, which is a memory address. Build a town with this string, and that's what a town takes, right? It's a string in the constructor. Yeah, takes in a string in the constructor. And that should give me a memory address, and I'm putting at bucket pause of collection of towns, which knows how to hold memory addresses. Oh, wait, it needs to be a town. It needs to be a town pointer. Because it's going to be a pointer to the beginning of a collection of things, each of which is a pointer. Make sure this is accurate before I explain what that just did. Let me just test something here. Town pointer T is equal to this guy. Then we'll do a C out on T, make sure that gives us a memory address. Then we'll put T, a bucket pause of that guy. Comment that out for now, so I won't try to display stuff. Yeah, so it is going to be a town pointer. That's fine. That answers the first question. I just want to make sure that I have oh, did I need to update my prototype now that I'm returning a town pointer, and I'll explain why that is in a second after I prove that this is the right thing. Town pointer, he's going to return a town pointer. So this guy's going to hold a town pointer. Okay. So now I should be able to say that. We get our sock fill. Okay. Let me explain what's going on here. Because this should look kind of scary to you right now. But let me actually show you where you've seen something similar to that before. When you first saw main, you probably saw something in there kind of like int argc char pointer argv. Can I remember that? And I kind of mentioned that, oh, well, this is actually another way of writing this would be int argc char pointer argv array. Now, if we keep evolving towards our modern languages, this is int main int argc string argv. That's effectively what that is. All right, so let's break this stuff down first so that we can then talk about what this is actually happening. So this is our least or our most primitive version of this guy. So when I say I have a char pointer, that pointer says I'm making an array, right? And when we have an array of stuff. What kind of stuff are we holding in that array? We're holding those guys. A char pointer is a string. Because what's a string? It's a collection of chars with a pointer to the very first char in that string, the base address of that string. So if I have a char pointer, what I end up having is a pointer to the beginning of an array that holds a bunch of pointers that point to the actual strings. So the char pointer points to the beginning of the array, and that array, each value of the array is a char pointer, which points to the beginning of the different strings. Similarly, in our current example with town, I'm having a town pointer that is an array of towns. How are towns stored? They're stored as memory addresses. So what lives in every single bucket of my array? So that the first part, town pointer, is an array, and it's an array of pointers, which point to actual towns. So if I have 10 elements in my town array, an array, any kind of array, will hold a pointer, right? It's going to hold, so you cannot make an array without holding a memory address. So anytime you're going to create an array, that asterisk is required if we're using pointer syntax for it, instead of the syntax, the bracket syntax that I said is basically never allowed, because it's that side effect of you lose the memory once scope ends. So if we look at just this part right here, every single time you ever create an array, you will always have that pointer there, the asterisk there, because by definition, arrays hold, the variable for an array holds the base address of that array. Arrays always hold things. What kind of thing is what comes next? So in this case, if you're holding an array of strings, you're going to be holding an array of char pointers. If you're going to be holding an array of towns, you'll be holding an array of town pointers, because that's what a town is. When you create an instance of an object, you get a memory address. You don't get the town. You get a pointer to where that town actually lives in memory. That makes sense? So that's why, and you might prefer it looking like that. So this is an array of this kind of thing, town pointers. I wonder if it'll let us get away with that. It certainly looks like funky syntax. Yeah, it doesn't like the parentheses in it. And that's more of a compiler tokenizing thing. The way that looks would be pseudo code for what I said. That is, this is an array of this kind of thing. Hence the town pointer. Make sense? If I had an array of ints, it would look like int pointer. This is an array of this kind of guy, integers, as opposed to an array of that kind of guy, town pointers. All right, does that make some sense? All right, let's make sure we're still in a working mode here. Okay, so now I have a function called getTowns that's going to read in all my towns and give me my array of towns. Now I am interested here. The town size of. I'm pretty sure we're going to have the problem of not knowing how many towns we have. Yeah, so we got 8 out of that, which is 8 bytes, which is the size of a memory address on this system. 64 bits. That doesn't tell us how many elements are in this array. So when we get this array back from get towns, we actually don't know the number of towns that were in that array. Does that make sense? Well, how do I get that? So we're going to keep going down the line of problem solving. Okay, so now I've solved the problem where I can have we're still dealing with, modernly, we have data representation languages like JSON or XML that would be a more, I guess a more compatible format for storing things. That way the data itself has the meta information and about what you're storing. If you read a JSON file, JSON is always in the same format, where even if we're asking for people to give us inputs here for our towns, we are still requiring them to know that I require you to give me a list of town names, 1 town per line. I'm having to give them that information. All right. But I don't want to have to search for a JSON library for C++ that will work in here. So we're not going to go down that path, and we're not really focusing on the file IO, other than just reminding ourselves that, hey, you know what? Computers have files on them, and sometimes you might want to store stuff in a file and read it into your program. That's something that we actually still do, even though it's something that we don't commonly do in programming classes. All right, so we solved that problem by saying, oh, well, the way I can have you give me a single list of city names, and I can make sure I build an array with the correct number of elements in it for your list of city names, is I'll just go through that file twice. I'll count it the first time, and then I'll build my array the second time. That makes sense? So we solved that problem. What's our new problem? New problem when get towns returns, it gives a pointer to the base address of the town pointer array. But we do not know how many elements are in that array. How can we fix this using what we currently know about C++? So this problem that's popping up should bring light to a couple different things. First of all, it should make us appreciate languages like Java a little bit more and C# a little bit more, because these languages have a more evolved array type, where we can ask an array, how big are you? How many elements? In Java, it's, if the name of the array is AR, we can say AR.length, and that will tell us the number of elements that that array can hold. Does that make sense? C++, we don't have that. So since we don't have that, we can still MacGyver this solution where we need to say, okay, here's the problem. I have a function, and in that function, I know. So what do we know inside of the function? We know the size of the array in the variable count. We know the pointer to the base address of the array in the variable, what did I call that guy? Collection of towns. So what do you think? How do we fix this problem so that ultimately get towns return something that gives us all the information we need to use that array? That is the base address of the array, as well as the size of the array. So really the question I'm asking is, how do we have a function return two different values? Knowing only what you know so far. Go ahead. Okay, so I'm going to say that is a very primitive correct answer. So he said, hey, let's do this. You want to return two values? No problem. Make an array with two buckets, put in one of the buckets, the value, in this case, the base address of the array. In the second bucket, put in the number of elements. The question for you, what's the type of that array? Because you're telling me you're going to have an array with a memory address in it, as well as an int in it, right? So it's going to be difficult to build an array. You actually can pull it off in C++ by making the array an array of void pointers, and then store in there in bucket 0 the base address of your town as a void pointer, and the count as a void pointer. So you'd have to pass it the address of your count. So you could pull it off, but this is probably not the best the best solution. But the point is this is kind of this idea of what programmers do. And it's been kind of somewhat fun, I guess, maybe frustrating at times, but because we are stuck with what this online GDB thing allows us to do sometimes, it's like giving us a pretty cool tool in a web browser, but you're also a little bit, sometimes your arm is tied behind your back if whatever they are doing to make this work doesn't jive with, a traditional like Linux operating system or something. But it's kind of fun if we think of ourselves as these problem solvers, and you have your toolbox in front of you and you say, okay, this is the problem you're going to solve. And you just say, okay, well, I got a screwdriver, I have some duct tape and a hammer, and we're going to fix the house with this one way or another. So, I mean, I like the answer he gave. I mean, it's not like an overly elegant answer by today's standards, but hey, in a pinch, it'll get the job done. It's no worse than duct tape. I mean, I think I probably shared it in another class. I one time fixed a door jamb, like a major issue with a door jamb with a lot of Kleenex. And there was duct tape involved too. I mean, we sold the house with that repair. There was another time in our basement of my current house, we were cleaning up stuff. My wife asked if this one t-shirt was load bearing. And that was a meaningful statement because it looked like I had tried to repair something by wedging this t-shirt into this place. And we didn't know if it was safe to unwedge said t-shirt from wherever it was. Okay, so certainly a possible answer, right? Okay, anything better? So his solution would allow us to return two values with one return type. My return type would be a void pointer array. How else can we pull this off? What might be a little bit more evolved way of pulling the same thing off? Do we have any ability in any of our programming languages to create something that allows us to hold more than one value, and those values don't have to be the same kind of type? Anything? I mean, we can kind of go to the record here. Maybe look at road. Does this guy hold more than one value and they're not all the same type? Yeah. So we could return an object. We could create a class, right, called town array object or something like that. and say, this guy knows how to hold a pointer to the base address of the array, and he also holds the length of the array. We could do that, couldn't we? Now, the reality is this is probably, well, this might be how they've actually implemented this inside of Java. Because from our perspective, what are we doing with arrays? From our perspective with arrays, we have an array. We're just saying, hey, give me your length value. Well, that's one additional thing an array can do over C++. But that's a pretty powerful extra thing. That solves a real problem, a real dilemma that we're having here, right? So realistically, if we're thinking like an old school C++ programmer, we might say, you know what? A struct is actually probably enough. We don't need to have all these methods and stuff associated with it. I just need to hold two pieces of information. I want a town pointer, an array of town pointers, and I want the number of things in that array of town pointers. Okay. But I would say that the modern programmer is not a struct-aware creature. We are object-aware creatures. So our version, our modern version of a struct is building a class with very limited functionality. So it would be a class with two fields. And you want to make them public, you can. Probably good programming practice would be make them private and then just have getter functions to get the array and to get the length, those two things. So for our homework, add the ability to our current code for get towns to return two values, the array and the length of the array, in a single variable type. This way we'll see who actually listened to the lecture. Okay, but we've said publicly here that a class would make a lot of sense for this. Everybody's good with that? If you want to try a struct, you can, it'll be easier, but the most appropriate solution for a modern programmer would just write a class that does this. Submit the self-assessment and a link to the code. Let me make sure I save this current code. Make sure it's still giving me stuff. Take out the confusing thing here. So that'll be our starting point for this guy. Questions, comments, concerns, bribes. So shouldn't take too long. We already have working code. Just gonna change your return type for that function and make sure you're consolidating this idea of, hey, I need to return two things as one thing. I need to build a class to do that. Sound good? All right, I will see everybody on Friday. CU launch presentations are tonight at 6 p.m. That's that entrepreneurial competition. It's down in the collaboratorium. If you are interested in watching the pitch events and seeing these people with something they only probably spent 4 or 5 hours on, make $2,000 and then kick yourself for not getting involved, maybe go down, go down and check that out. And then do CU launch next time, because it's a pretty easy way to make some dough and learn about building a business model.